Okay. Welcome to this problem section on basic graphs, and I've prepared a few problems A, B, and C. And this one says, problem A, make a table of values for these problems using multiples of pi over 4 for x, then use the entries in the table to sketch the graph of each function for x between 0 and 2 pi. The two functions we're going to graph, and these are only the points. Certain points for these are cosine of x and cotangent of x. Here are the x values in radians, so 0, pi over 4, pi over 2, 3 pi over 4, pi, and so on. I put them already in there, and I calculated already the cosine x here. Okay, that's not true actually. By now we have them memorized, so we have 1.7070, negative 0.707. We're in quadrant 2 here, and the cosine has become negative. Of course, when I graph, I cannot graph more than just a 0.7 anyway. You know, I'll leave it here. Of course, this is the correct number, but I cannot graph more than just 0.7. And the cotangent, which is undefined at 0 because it's the inverse of the tangent, which is 0 at x equals 0. And then 1 at 45 degrees, just like the tangent is, and then 0 at 90 degrees because that's where the tangent is undefined, and negative 1 at 45 degrees, I'm sorry, 135 degrees, because here we're in the second quadrant for the cotangent, and so on. So I have prepared all these values already. I'm going to go to sketching these points. So there we go. Okay, and I better move this over a little bit. Okay, so here I'm going to do single points. I hope this is going to work out. They're going to be a little bit thick here. You see the scale that I have here. So I have 1, 2, 3, and so pi is just beyond the 3, and then 2 pi is just beyond the 6. And I stretch it a little bit in the y so that we have 1 here and 2 up there. So I'm going to go ahead and do the cosine for x equals 0, which is here, and then 0.7, where we have pi over 4, so 0.707. No, that's not true. I actually have to try that top of my head. Pi over 4 is the same as 0.8 virtually, so I'm about here, and then pi over 2 is going to be here at 0, and 3 pi over 4 is approximately here. Whoa, sorry about that. And negative 1 is going to be here. Oh well, I guess either way the points come out. Then negative 0.7 is approximately, let's see, here. And then 0 is going to be here, close to 5. And then 0.7 is approximately here. And 1 is going to be over here. So that's how the cosine would look like. And then, of course, we would try to connect the points, which is actually part of problem B that we're going to come across in a few minutes. Okay, the other one is the cotangent. So I'm going to do that one. So again, I'm going to start here. Cotangent is undefined at 0. Then it's 1 at pi over 2, so approximately here. Then it's 0 at pi over 2. Then it's negative 1 at 3/4 pi, which is approximately here. Then again, it's undefined at pi itself. It's 1 at 5 pi over 4, which is, calculating this on the side here, almost 4. So we have 1 at almost 4, that point. 0 at 3 pi over 2, which is approximately here, and 7 at 7 pi over 4, we have -1, which is 1.75 times pi, comes out to 5.5, so that's approximately here. And then again, it's undefined at 2 pi. And we can imagine that the graph of this one here is going to look like this. Like this. And then, of course, going into infinity. It says in the problem, sketch it. So my sketch is going to be more or less accurate. I'm using the mouse here to draw, so I'm not, for which I have even less dexterity than if I actually used a pen and drew it freehand. Anyway, in problem B, we are supposed to sketch the graphs for cosine, secant, and tangent for x between -4 pi and 4 pi by extending the graphs we just made, but of course I didn't make the tangent or the secant here, so I have to kind of start over for those. It's okay. Here's the cosine. It asked for the cosine. So this is the way it would look like. We would connect these here. Try to make a smooth curve through it. Respectively, they're asking in problem B to go from -4 pi to 4 pi. So I'm going to go to that. Here we go. All right. I like to start actually here at 0 and 1, of course, for the cosine. And then I'm going to hit 0 wherever pi over 2 is, which would be here. Then I'm going to hit -1 where I have pi. Sorry, I missed that a little bit. And then I have 0 here again. I'm back to 1 where we have 2 pi. And then I'm going to have this. Ooh, this is going to be a little bit out of sync here. It was a little steep. Okay, now I messed up actually. So I'm going to say undo. Oops. Okay, I guess I start over again. So I'm going to come up with this one here. Then I'm up here. Then I'm here. Again, this is with my mouse. And I'm back up. Ooh. Here. Whoa. Let's see if I have an eraser somewhere. I guess I do. There we go. All right. And then I extend it the same way into the negative. So here we go. And at -2 pi, I'm back up to 1. -3 pi, and then I have to scroll over a little bit. And I'm up here. So that's how the cosine x looks like, repeating itself. Okay, secant, which is the inverse of the cosine. So if you imagine that we have a 1 here, the inverse of that is a 1 as well. So for the secant, we would get a little cusp right here. Then it would increase as the cosine is decreasing. The secant would increase, and it would hit infinity right here. And then over here it would do the opposite, so we're going to get a cusp or an upside down trough right down here. I'm going to do that on the next graph. In fact, I'm going to do a little bit of a trick here. I'm going to take this one, copy it, and trying to make it easy on myself. Use a different color. Red, I guess. And as I said, I'm going to go here, and then I would get about to infinity right there. To infinity about right there. And here it would look the opposite. And here you go. And here you go. And so on. And I guess I need one more over there. There you go. Yeah, it becomes a little bit tough to draw this here freehand with a mouse. Now I could take the eraser here, and because I had copied this here, I could get rid of the cosine itself. Yeah, it's kind of just playing around. There. There we go. So that's the cosecant. I'm sorry, that's the secant. The cosecant actually looks kind of similar. It would be just shifted a little bit over. Okay, the tangent. So the tangent would start here at 0 and then go all the way up to infinity where it hits pi over 2. That was a little bit too slow actually, so I'm going to take this off here. So there we go. Okay, then it comes from negative infinity and then hits pi right here and goes again to infinity. And then that looks kind of good. And it's the same thing here. And we already can see that the tangent is faster than the other functions. The other functions have a periodicity of 2 pi repeat themselves every 2 pi, while the tangent repeats itself every pi, so it's faster. Cotangent, of course, does the same thing. Let's see. Oops, that's a little bit off. In this, oh gosh, I think I'm going to quit after this one here. You do see in the script I have some other drawings. I had done this lecture before, and so I used different drawings from previous time. So I'll repair these here maybe. Okay, a little bit better. Whoa, okay, never mind. I quit on this one here. Okay. Problem C says, find all values of x for when cosine equals 0, sine equals 0, sine equals 1, cosine equals 1, tangent equals 0, and where the tangent is undefined. For values between, let's see, 0 and 2 pi. I'm going to go back here for the cosine. So it says that the cosine is 0. Well, the cosine is 0 at pi over 2, 3/2 pi. And I said those are only between 0 and 2 pi. So that's where the cosine is 0. The cosine is 1 at 0 and at 2 pi. So we keep that in mind. The tangent is 0 between, or 0 at 0 itself, pi and 2 pi, and the tangent is undefined at pi over 2, 3/2 pi. Yeah, those two in between 0 and 2 pi. So I'm going to go over back to Word and fill in these values. Okay. Let's scroll down, and there it is. So here it says find all values, and towards the bottom of the page. So cosine x equals 0 at x equals pi over 2 and 3 pi over 2. And that's what it says here. The general one to write down would be x equals pi over 2 plus k over pi, with the k being an integer. Could also be a negative number, so we also would extend this into a negative. The other one was cosine x equals 1. Well, we have that at x equals 0, as well as at x equals not pi, because that's where it's negative 1, but at x equals 2 pi. And again, this is the rule here that says, well, at 2 pi, and of course at 0 times 2 pi, which is 0, and so on. Tangent x equals 0, we found out, well, it's 0 at 0 itself, it's 0 again at pi, and it's 0, and the tangent, and it is also within the rule that says k pi in general. And tangent is undefined at pi over 2, 3 pi over 2, and I believe these were the only ones inside the interval. And then we didn't graph this one here, but you can do this on your graphing calculator or sketch it yourself on some graph paper. Sine equals 0 would be, of course, at x equals 0, as well as pi. And again, that's what the rule says. Sine equals 1 happens at x equals pi over 2, and then not at 3 pi over 2, but 2 pi later, so that's outside the interval that we're asked for to do this here. So inside the interval, it only hits it once at pi over 2. Okay, and with that one, we're finished with the problem section on section 4.1 basic graphs.